Good afternoon, ladies and gentlemen. Thank you for being here today. My name is Viktor, and I'm pleased to welcome you to this tech talk on predictive application development using artificial intelligence. Let's get started. So, what is the problem we're trying to solve? We all interact with AI in some way, whether we realize it or not. Overall, the capabilities of AI are quite impressive, especially when we see them showcased in demo presentations. It's clear that AI is a powerful tool with a lot of potential. However, as a developer, I'd like to share a few thoughts about one important aspect, the predictability, or determinism, of AI results. Personally, I've noticed that using AI to generate code can sometimes feel a bit like playing a slot machine. The results often look impressive, but there's an element of unpredictability. Each time you try, you might get a different outcome. This unpredictability isn't always a drawback. In some cases, it can even be helpful, especially when you're looking for creative solutions or exploring new ideas. However, if you're trying to build an application and need consistent, repeatable results, this lack of determinism can become a challenge. It all comes down to how complete and detailed your request to the AI is. A common way to illustrate this is with the iceberg analogy. The part above the water, the tip of the iceberg, represents the small, simple request we make to the AI. But beneath the surface lies a much larger portion, all the hidden details and context that are actually needed to fulfill your request. Since these details aren't always specified, the AI fills in the gaps on its own, making choices that can be unpredictable. It's important to remember that artificial intelligence doesn't truly understand your request. Instead, it transforms your input using patterns and templates learned from its training data. It's about transformation, not real understanding. Even a well-crafted prompt can't always provide a large language model with everything it needs to generate exactly what you want. Even a well-designed request cannot satisfy all of the model's needs for high-quality generation of your desired result. In theory, an ideal prompt would give the AI all the information it needs about an application, such as requirements, features, context, constraints, and examples, leaving nothing to guesswork. However, in practice, this isn't realistic. Creating such a detailed request would mean describing every aspect of the project in full detail, which is essentially like coding the program in human language. This approach defeats the purpose of using AI for abstraction and automation. It also highlights a key challenge, finding the right balance between providing enough detail and keeping the process efficient when designing your prompts. When a query contains only limited information, AI tends to fill in the gaps by relying on random patterns from its training data. This can result in unpredictable or even irrelevant outcomes, as the AI essentially tries to guess what you want. This phenomenon is sometimes called the kid in a candy store effect. When the AI is given too many options and not enough direction, it makes random choices instead of focusing on what's truly needed. To avoid unnecessary randomness, it's important to limit the AI's variability and provide clear guidance. Well-defined guidelines help the AI concentrate on relevant solutions and reduce the influence of any missing or undisclosed details. To address this problem, we need to guide the AI in the right direction by ensuring it has access to the additional information required to fulfill the request. One effective way to do this is by setting clear boundaries for the task. Task limitation helps AI agents deliver more predictable and valuable outcomes by reducing distractions and narrowing their focus. Much like horses wearing blinders, restricting the AI's options allows it to concentrate on the task at hand. This targeted approach increases the likelihood of achieving successful and relevant results. By setting clear boundaries and focusing the AI's attention, we make its output more predictable and relevant. Instead of giving the AI an abstract description and asking it to build everything from scratch, we can guide it to create an application using components we already have. This approach is similar to assembling a puzzle. It's much easier to put together a picture from existing pieces than to paint it entirely from scratch. When we use predefined fragments, the outcome is more controlled and aligned with our expectations. Unless we need something completely original, this method should meet our needs. Additionally, this process requires less specialized skill and is much faster than starting from a blank canvas. Perhaps the puzzle analogy feels a bit outdated, so let's use Lego parts instead. In reality, AI doesn't build applications entirely from scratch, it assembles them using well-known libraries and components it has learned about during training. This is actually beneficial, because familiarity with these libraries will be useful for us as well. Our own libraries will likely rely on them, too. Beyond just functionality, our libraries can also provide important contextual information, helping the AI understand how to assemble the application in a way that fits our specific needs. This approach depends on having access to the right libraries and selecting them appropriately. When we talk about libraries, it's important to clarify that we're not referring to general-purpose libraries like Spring or React. Instead, we mean libraries that are specific to the business domain. For the purposes of this presentation, we won't discuss where these libraries come from, let's simply assume they exist. The next crucial step is choosing libraries that truly fit our requirements. This approach only works when we can confidently recommend libraries that match the needs of our application. To achieve this, we need to address several key tasks. Searching for libraries that could potentially be used, analyzing and evaluating them, selecting the best options. By following this process, we ensure that only the most relevant and reliable components are used, creating a strong foundation for successful application development. To make this process work, we need a clear description of each library, a manifest designed specifically for AI-driven assembly. Let's call this manifest the Bindex, short for Brick Index, the index of our library's Lego-like parts. The Bindex serves as a foundation for automated application assembly, helping to answer three critical questions that developers, or AI, encounter when working with libraries. What is this library? Where is it located? How do you use it? In summary, the Bindex provides essential context by organizing and describing libraries. This enables artificial intelligence to make informed decisions when selecting and assembling components during application development. By structuring information about libraries and providing detailed metadata, such as key signatures and usage examples, the Bindex enriches the context of the query with valuable data. This leads to more accurate and predictable results. Of course, the AI will still encounter many undisclosed details and may produce some unpredictable results. However, overall, code generation, even with less detailed queries, will become more predictable. Importantly, the generated code will utilize components that are likely familiar to your team, since we are focusing on corporate libraries. Now, we arrive at the stage of building the application, a process we'll call AI assembly. AI assembly is a system that automates application creation by intelligently combining selected libraries and components, guided by the Bindex repository. It integrates these libraries into a cohesive application structure, automatically generates code for connecting and configuring components, ensures compatibility, and optimizes integration. This approach reduces manual work and accelerates development. By using AI assembly, developers can streamline the creation of reliable applications, save time, and minimize errors. The overall process can be summarized as follows. The developer submits a request to the AI assembly engine. Relevant libraries are searched and selected. The application is assembled automatically. That's all there is to it. The next part of the presentation will focus on the practical implementation of compiling applications using indexed libraries. Let's explore some of the technical details involved. Of course, all the code generation work will be done using a large language model, LLM. GenAI is still a relatively young technology, but there are already many services that offer access to their models. In addition, a variety of tools have appeared that act as intermediaries between users and LLM services. These tools simplify interaction by preserving chat history and enriching queries with context, which helps provide more accurate and relevant answers. The approach to building applications described here can be implemented using various tools and patterns. In particular, we have in mind RAG, Retrieval Augmented Generation. Next, I will discuss the practical implementation of the AI building process using the example of the open-source Machai project. Machai is one of the projects within Machanism.org, an organization focused on initiatives related to artificial intelligence. For more detailed information about the Machai project, you can visit its official website. Ghostwriter is a key project within the Machai ecosystem, designed for processing user files with AI. It scans project files, detects embedded at guidance tags, and leverages generative AI providers to create or update content directly within the project's working tree. Ghostwriter also supports AX files, which enable the use of reusable query templates and provide tool functions for automated workflows. In our approach, AX will be used to build applications by utilizing the registered libraries in our Bindex repository. This diagram illustrates how users interact with Ghostwriter through the command line interface, and optionally via the Maven plugin. Ghostwriter supports two main processors, the guidance processor, which handles tag processing, and the ACT processor, which executes AX. Both processors operate within a shared processing pipeline that scans, filters, and processes files. This pipeline is capable of handling various file types and can also interact with specialized functional tools. For AI-related tasks, the pipeline interacts with an AI provider manager, which executes service requests through an API. The system also includes functional tools for resource interaction, such as accessing the file system. It can read and write files, make requests to external URLs to retrieve content, and perform other similar operations. For more detailed information, please visit the project's official website. Ghostwriter leverages the specialized Bindex core project, which provides the essential runtime environment for managing Bindex metadata. Bindex core focuses on describing software libraries and projects as structured metadata, enriching them with embeddings for semantic search, and storing these records in a database. It also offers functional tools for invoking libraries using artificial intelligence. The project integrates repository services, semantic recommendation logic, and AI tool registration into a single library. It supports creating and updating metadata records, retrieving them by identifier, loading a JSON schema that defines the metadata format, and recommending suitable libraries based on natural language queries. This diagram illustrates the main components and interactions within the Bindex core project. The large language model, LLM, can invoke library registration and semantic selection through dedicated tool functions. Bindex function tool serves as the entry point, registering AI tool functions such as get_bindex and pick_libraries. Bindex repository is a vector searchable repository responsible for storing and retrieving Bindex JSON documents. The picker component selects libraries using Bindex, performing semantic searches with embedded AI and vector search capabilities. For more detailed information about the Bindex core project, please visit its official website. Without real libraries and proper indexing, the system cannot function effectively. For this reason, we will use libraries provided by Machanism.org. If you'd like to learn more about Machanism.org, you can visit their website. For now, it's sufficient to know that these libraries are available and can assist us in building applications. Currently, there are 3 crystallization projects available for different technology stacks. For our demonstration, we will begin by using the libraries from the Macha project, which is focused on e-commerce and Java. As you can see, there are currently a total of 145 libraries available. Let's now move on to the demonstration part of the presentation. Since I plan to use Machai and Ghostwriter via the command line, the first step is to download it from the sourceforge.net website. Next, I specify the necessary configuration data. For convenience, I've also created a batch file and set its path, allowing it to be executed from anywhere. With these preparatory steps complete, we're ready to proceed with creating the application. Let's begin by opening 2 console windows in different directories. Now, we'll start 2 application assembly processes using the same request in each console window. Assembly create a Spring Boot REST service for user authentication via Commerce Tools. Since our goal is not just to set up a project based on a request, but also to design a system that assembles projects more predictably, we launched 2 projects simultaneously to compare their outcomes. These projects are assembled independently and have no knowledge of each other. To save time, the assembly process has been accelerated by a factor of 10. As you can see from the logs, the results are different. The assembly act is interactive and can ask clarifying questions. In this case, the process on the left did not prompt for any clarification and completed its execution. The process on the right, however, was more inquisitive and took the opportunity to ask for additional information. I agreed with its suggestions, and it also completed successfully. Both projects finished without issues. Let's now review the results of their work. Let's start by comparing the pom.xml files from both projects and evaluate how different they are. For example, the commercetools common dependency, which appears in the right project, isn't strictly necessary, it's already included through other dependencies. The same goes for the configurator in the left project. Overall, we can see that the 2 files are almost identical. Next, let's open both projects in the editor and take a look at their README files to see what information has been generated. It's clear that the projects are not identical. The project on the right includes a user registration endpoint, while the one on the left only provides a login feature. Additionally, the configuration of the Commerce Tools client differs between the two projects. Let's begin with the project on the right. First, add the Commerce Tools client configuration to the environment variables, as outlined in the README file. Then, click Run. The application started successfully. Next, let's call the service to register a test user. Let's verify that the test user exists in the Commerce Tools Merchant Center. Everything appears as expected, the user was created successfully. Now, let's run the project on the left. After making the necessary configuration changes for the Commerce Tools client, we can start the server. The application launched successfully, with no errors. This project does not implement user registration, so we will proceed by testing the login functionality. The login was authorized successfully. Here's a polished and professional version for your conclusion. In conclusion, I'd like to highlight the key takeaway from today's presentation. The demonstration showed that even when using identical queries, AI-generated results can vary significantly. However, leveraging indexed libraries through the Bindex system enables greater consistency and predictability in the projects created. This demonstrates that a structured approach, built on proven components, truly delivers results. For effective use of artificial intelligence in development, it's essential not only to craft high-quality queries, but also to provide AI with structured context and a limited selection of components. Bindex helps organize libraries, supply the necessary context, and make the code generation process more manageable. This can significantly improve the quality and stability of outcomes, making the development process more reliable. For further information and deeper insights, here are some media and links to additional resources. The Machai project also has a dedicated playlist on YouTube, where you can find additional presentation materials. These are short videos that demonstrate the capabilities of the Machai project and provide practical examples of its features in action. For a broader overview of the entire Machanism project, you can explore video presentations available on the MachanismOrg YouTube channel. These videos offer insights into various initiatives and technologies within the Machanism ecosystem. And of course, there is the main website, www.machanism.org. This resource provides links to subsidiary projects, including Mach-A, Mach-B, Mach-C, Mach-AI. Feel free to explore these sites for more detailed information about each project. Q&A section. In this section, I will address several questions that were raised during the Tech Talk, providing additional insights and clarifications on the topics we've discussed.
Is it possible to set up Bindex so that only the organization has access to it, ensuring that external users cannot use or view their libraries?
Yes, it is possible to configure Bindex for private, organization-only access. Bindex can be deployed within a corporate environment, ensuring that library descriptions and metadata remain accessible exclusively to authorized users within the organization. Access controls and authentication mechanisms can be implemented to restrict external users from viewing or utilizing the indexed libraries. This approach allows companies to maintain confidentiality and security while benefiting from the structured management and automation capabilities of Bindex.
Are there any automation mechanisms for populating the Bindex? Many corporations already have a large number of libraries with different versions. So is there a way to automate the process of filling Bindex with this information?
Yes, Bindex supports automation for populating its index with library information. There are tools and scripts available that can scan existing repositories, extract metadata from libraries, including different versions, and automatically add this data to Bindex. This helps organizations efficiently manage and update their library index without manual effort, ensuring that all relevant components are accurately represented and searchable. However, in special cases where libraries have unique configurations or require additional context, manual updates to the automatically generated Bindex may be necessary. This ensures that any specific requirements or custom details are accurately captured and reflected in the index.
Does Bindex support updating existing libraries? For example, if a library depends on other corporate libraries of specific versions, and those dependencies are updated, can Bindex help automatically review compatibility and update the libraries accordingly?
Yes, Bindex is designed to help manage and update existing libraries. It can track dependencies between libraries and their versions, allowing you to review compatibility when updates occur. With its structured metadata and semantic search capabilities, Bindex can identify which libraries are affected by changes and assist in updating them. Automated tools can be used to scan for updates, check compatibility, and recommend necessary changes, making the process more efficient and reliable.
Who will be responsible for creating and describing the metadata for the libraries?
Typically, the responsibility for creating and describing library metadata falls to the development teams or library maintainers within the organization. Automated tools can assist by generating basic metadata, but for more detailed or specialized information, manual input may be required. In some cases, organizations may designate specific roles or teams to oversee the quality and completeness of library metadata, ensuring that the Bindex remains accurate and useful.
You raised an interesting issue about using a limited set of libraries within a project, specifically generating applications by leveraging only those libraries. When you started developing your solution, did you review existing alternatives? Since this is not a new problem, developers in other areas have faced similar challenges before. Did you consider or evaluate any existing solutions before deciding to implement your own?
Yes, before starting the development of my solution, I did review existing alternatives. There are several tools and frameworks that address similar challenges, such as package managers, dependency management systems, and some AI-assisted code generation platforms. However, most of these solutions either focus on general-purpose libraries or do not provide the level of structured context and fine-grained control needed for assembling applications from a restricted set of business domain libraries. This gap led me to develop a custom approach that emphasizes structured metadata, semantic search, and controlled access to corporate libraries. By doing so, the solution better meets the specific needs of enterprise environments where security, predictability, and context are critical.
Thank you for your attention and participation. We appreciate your interest in AI-powered application development. If you have any questions or would like to discuss any aspect further, please feel free to reach out at feedback@Machanism.org.